The composition of two functions is also called a composite function. Assuming we have an element in the domain of a composite function, we'd like to evaluate these types of objects. This is going to be done by evaluating the inner function using the starting input, then using the inner function's output as input for the outside function. Let's go ahead and draw a picture and see what's going on here. Over here we have a function whose domain contains 3, 2, and 1, and whose range contains 4, 5, and 6. Let's call this first function f, where we have 3 goes to 4, 2 goes to 6, and 1 goes to 5. Now, let the range of our function f also be the domain of a new function. We'll call this function g. So again, the domain of g is given by the range of f. So we have 4, 5, 6. Let's also suppose that the domain of g has an extra input. We'll call this extra input 7. And the range of our function g is going to be given by the numbers a, b, c, c here, and d. G assigns 4 to a, it assigns 5 to c, and 6 to b. 7 goes to d. If we wanted to define a composition of functions, g composed with f, then we do it the following way. First, the domain of g composed with f is restricted to the domain of f. So the domain in our new composite functions has 3 elements, 3, 2, and 1. Then we're going to go ahead and see where 3 is sent to under our composition function g composed with f. In our function f, 3 goes to 4, and then in our function g, 4 goes to a. So our composite function is going to send 3 to a. In our function f, 2 is sent to 6. Then in our function g, 6 is sent to b. Therefore, in our composition of functions, 2 is going to be sent to b. Doing this one more time, we see that f sends 1 to 5, and g sends 5 to c. So 1 is going to be sent to c. Oh, I'm sorry. I realized I made a mistake in the last one. This shouldn't be a 2. This should be a 6. Nope, a b. Writing down some of these terms, for example, g composed with f evaluated at 3 is going to be equal to a. G composed with f of 2 is going to be equal to g composed with f of 2. We saw that this is equal to b. A helpful picture to hold on to whenever you're thinking of the domain of composite functions is going to be the following. Here we have our domain of f, and over here we have our domain of g. Under our function f, f takes the domain of f to the range of f, and the range of f has to be contained inside our domain of g. Now over here again we have the function g, and we also have the range of g. Underneath our map f, our range of f is taken to some function over, some subset over here inside the range of g. Again, this gives you a good idea of what's going on, but it's not an exact picture. Let's go ahead and evaluate some composite functions. Given f of t is equal to t squared minus t, and h of x is equal to 3x plus 2. Let's go ahead and evaluate the following. H of f of 2 And we're going to also evaluate h of f of negative 2. And part C, we'll do 3 f of 1 plus f of h of a. In part A, there's different ways to do this. Let's go ahead and first find what f of 2 is. Evaluating f at 2, this is going to be equal to a 2 squared minus 2, which is equal to 2. H of f of 2 then is going to be equal to h evaluated at 2. Evaluating h at 2, we get that this is equal to 3 times 2 plus 2. This is going to be the solution to part A, which is equal to 8. In part B, again, let's go ahead and evaluate f of negative 2 first. This is going to be equal to a negative 2 raised to the second power minus 2. This is again going to be equal to, ooh, sorry, I made a mistake here. That's not a 2 here. That should be a negative 2. This is equal to 4 plus 2, which is equal to 6. Continuing beyond, again, we're looking for h of f of negative 2, and we just found that f of negative 2 is 6. We want to evaluate h then at 6. Evaluating h at 6, this is going to be a 3 times 6 plus 2, which is equal to 20. In part C, we're looking at 3 of f of 1 plus f of h of a. Let's do this one step at a time. First, we'll evaluate f of 1. This is going to be equal to 1 squared minus 1. This is 0. Therefore, this is equal to a 3 times 0 plus f of h of a. And then we only need to really find f of h of a. Let's go ahead and solve for evaluate h of a. H of a is going to be equal to 3x plus 2, not 3x, 3a. Then this is equal to f of 3a plus 2. Plugging in 3a plus 2 into our function f of t, this becomes 3a plus 2 squared minus 3a plus 2. This is going to factor out to be a 9a squared plus 6 12a plus 4 minus our 3a minus 2. Combining like terms, we have a 12a and a 3a, but this 3a is negative. This is going to become a 9a. Then we have this 4 here and this negative 2. Combining those together, we get plus 2. And we still have our 9a squared out in front. So this is our final answer. Another way of evaluating composite functions is we can replace x with f of x in our function first and then evaluate. In this next example, we're going to do this the alternative way. Example number 4. Suppose we're given 3 functions. F of x is equal to x squared plus 1, g of x is equal to 1 divided by x, and h of x is equal to x plus 3. Here, we want to find f composed with g composed with h of x. Part B, evaluate f composed with g composed with h of x at the point 1. Before we go any further, let me go ahead and write out an alternative notation to part A. This is going to be the same thing as f parentheses g composed with h of x, and this is going to be equal to f composed with g composed with h of x. Okay, part A. Again, we're trying to find this really big composite function. Let's do this one step at a time. Number one, let's go ahead and find g composed with h of x here. This is going to be equal to a 1 divided by h of x, which is equal to a 1 divided by x plus 3. 2. Let's now look at our f composed with g of h of x. We just found that this g of h of x is equal to 1 over x plus 3, so we can replace this with a 1 divided by x plus 3. And then our x is going to become our function f is going to be equal to 1 over x squared plus 1 raised to the second power plus 1. Rewriting this is going to be equivalent to 1 over x squared plus 1 squared plus the number 1 here. Let me go ahead and start a new page. Writing out what we just had, we had 1 over x plus 3 squared plus 1. So foiling this out, we get that this is going to be 1 over x squared plus 6x plus 9 plus 1. And now we want to combine this into one function here. So to combine this into one function, what we need to do is we need the denominator of both of these fractions. So technically this is a fraction here. We need the denominator of this fraction to be equal to the denominator of this fraction. So multiply the top and the bottom of 1 by x squared plus 6x plus 9. We get the following. Adding fractions together, the denominator doesn't change, but we add the like terms in the numerator. This becomes then divided by our original denominator. All right, so this is the answer to part 1. So let me go ahead and copy this real fast. Place it on this next page here. In part B, we want to find f of g of h evaluated at 1, where what we found in the last part was f of g of h of x. To evaluate this function then, all we need to do is replace all the x's in this function above with 1. This then becomes a 1 squared plus 6 times 1 plus 10 divided by 1 plus 6 plus 9. Simplifying the top, we get 17. Simplifying the bottom, we also get 16.